Bismillahirrahmanirrahim. Chapter 10, Lesson 4, Inscribed Circles. Our main objective is to identify and apply relationships between inscribed angles, arcs, and central angles. And then our second objective is to apply the relationships between angle formed by a chord and the tangent to its intercepted arc. Clear? So here, look at this one. This part, this is the arc. This is the arc of the circle. We will call it the intercepted arc, and the angle that is, you can say, standing on this arc, or you can say, if I divide the circle into two segments, so I have the arc in this segment of the circle, and if on the same arc, if I draw an angle that has the endpoints on the endpoints of the intercepted arc, then this angle is on the opposite side of the segment of the circle. In the opposite segment, this angle is called the inscribed angle. Let me show you here. So look at this. What is an arc? Where my cursor is showing you the pink color, this is an arc of the circle. It is called the arc of the circle because it is part of the circumference. Now if you see the blue angle, this angle is called the central angle, and this angle has the center, this angle has the vertex at the center. Arcs can be measured in degrees. The degree central angle that creates the arc. Now look at this. This central angle is giving us this pink arc, and you can see here the measurement of the arc is 50. Let me make it, let's say 49. I'm trying to make it a whole number. Okay, let's keep it 49. Now look at this. What is the measurement of the arc? It's 49.27. And what is the measurement of the central angle, the one that is shown here with the green color? It's also 49.27. Even if I increase the size of the arc, look at this, I'm making the arc bigger. I have now made the arc 72.96. Same has happened to the central angle. So we can say that the central angle and the arc, they have the same measurement. So this is the main point you have to keep in your mind. Like even if they show you the central angle or they show you the measurement of the arc, it's the same thing. Now let me show you something else. Now I will move the cursor here. You can see I'm making the arc small. What is the measurement of the arc here? It's 80 degrees. What is the measurement of the central angle? It's 80 degrees. As I was telling you, that the arc, the red arc and the central angle, they have the same measurement. But this is the inscribed angle. The green one is the inscribed angle. What is happening to the measurement of the inscribed angle? It is depending on the size of this arc, the intercepted arc. When I'm increasing the size of the arc, right now look at this, the size is 104. Let me make it 100. So look at this, this is 100. What has happened to the inscribed angle? It has become half. Or you can say the opposite, like the inscribed angle is 50, so the intercepted arc is double of it, right? You can check it by making it bigger and bigger or smaller. It will remain, it is showing the same result. Like whenever we are making, let's say right now it's 98 and half of 98 is 49. So the lesson, it depends on, you can say, the inscribed angle and the intercepted arc. This red is the intercepted arc. This red dotted line is showing the central angle. The intercepted arc and the central angle, they have the same measurement, and this is the intercepted angle. It will always be half of this intercepted arc. Clear? Now let's see what do we have in the theorems. So here is the first theorem of the lesson, theorem 10.8, inscribed angles theorem. The measure of an inscribed angle is half of the measure of the intercepted arc, as I explained you with the live demonstration. Like always, this angle, look at this. Now I will show you the arcs with the red color. Now look at this, here is the arc and here is the arc. This is the intercepted arc, right? Now the angle is the inscribed angle. I will show it here to you with the green color. Now look at this. This is the intercepted angle. This is the inscribed angle. Now what will happen? This angle will always be the half of this arc, right? So it is mentioned here that angle S will be half of the arc RT. Similarly here, angle S is half of the arc RT. Now what is the difference between the three diagrams? Here the center is on one side of the angle. This is the center of the circle and it is lying on one side of the angle. Here the center is inside the angle, like the two legs of the angle are on each side of the center of the circle. And here they said the center of the circle is outside the angle. Look at this. This angle is this center is not inside the circle, inside the inscribed angle. Clear? The rule will remain the same because we have the arc, and in each of these three cases this is the intercepted arc and we have the inscribed angle. So in all these three cases the angle will remain the half of the intercepted arc. Clear? Here is a try it question. It says if the arc RST is 164, what is the measure of angle RVT? First let's decide where is the arc they are talking about. This is RST. So this whole arc is how long? It is 164. I'm solving right now 2A. Okay, now what is the angle that this is the arc? Okay, what is the angle that is, you can say, standing on this arc, or you can say the angle that is inscribed by this R. So it's this angle RVT. Now what is the measure of this angle? As we discussed in the theorem, this angle, this inscribed angle, will always be half of the intercepted arc, right? So we can say if we are trying to find angle, which angle we are trying to find, angle RVT, it will be half of the arc 164, right? Or you can say, if you divide 164 by 2, it will give you the same answer, right? So it's going to be 82 degrees. What are they saying in the B part? They are saying angle SPU. So let me erase this thing and I will show you what they are talking about now. They are saying angle SPU. Where is angle SPU? SPU, right? So they are talking about this angle. What is the measurement of this angle? It's 79 degrees, right? Now they want us to find the measure of the arc. Where is the arc? Which arc they are talking about? They are talking about arc STU. STU. They are talking about this arc. Now this angle and this arc, what is the relationship between them? It will always be, if you are talking about the arc, it will be double of this angle. So if I want to find the measure of arc STU, it will be 2 times of 79, because the arc measure is the double of the measurement of the angle. And if we talk about the angle, it is half of the measure of the arc measurement. Clear? So it's going to be 2 times 9 will be 18, and 14 and 15 degrees. Clear? So here we have some corollaries of the same theorem. Corollary number 1, it says two inscribed angles that intercept the same arc are congruent. It means that, for example, you have just one arc R, you have just this arc RU, and there are two angles. Let me show you the two angles with the different colors. Here, one of the angle is RSU, and the other angle is RTU. So these are the two angles. They have the relationship with the same arc, right? Or you can say that these two angles are they have the same intercepted arc. So it means these two angles will have the same measurement, because they are, you can say, they are standing on the same arc. They are made by the same arc, so that's why they will have the same measurement. So we can say angle S will be equal to angle T. Doesn't matter. Even if I draw another one, a third one like this, for example, R, P, U. So this angle P will also have the same measurement because this angle also is standing on the same arc, or you can say it has the same intercepted arc. What is the second corollary? It says an angle inscribed in a semicircle is a right angle. Now look at this angle RTS. So because if this arc RS, now look at the arc RS, let me show you this arc RS, it's 180 degrees. That means it's a semicircle, it's a half circle. So we know that if this arc is 180 degrees, what will be the measure of this angle? It will be half of 180 degrees, that will become 90 degrees. So it means that whenever we have an angle and the arc intercepted by it is a semicircle or 180 degrees, then the measurement of the angle will always be 90 degrees. Clear? Even if you draw this line over here, so you can say any angle that is standing on the half of the circle is 90 degrees. Clear? The opposite angles of an inscribed quadrilateral are supplementary. Now this quadrilateral, look at this, all its four corners are on the boundary of the circle. We also call this quadrilateral cyclic quadrilateral. Okay, this is a special quadrilateral. Why? Because it has all its four vertices on the boundary of the circle. Okay, in this case, if you have a quadrilateral like this, the opposite angles, their sum will always be 180. It means if you will add angle angle S with angle U, it will be 180 degrees, and if you add angle R and angle T, it will also be 180 degrees. So the opposite angles of an inscribed quadrilateral, this is the inscribed quadrilateral or cyclic quadrilateral, the opposite angles are always supplementary, or you can say they add up to 180. Clear? Now let's solve some questions we have another theorem, by the way. The measure of an arc formed by the tangent and a chord is half of the measure of the intercepted arc. How can you understand this theorem? Like for example, if you have a circle and you have a tangent. Now this point is called the point of tangency, and we have been given a chord at this point of tangency. Let's name it, let's say AB. Now what is the relationship? We have this arc and then we have this angle. What is the relationship between these two? So this angle will always be half of this intercepted arc. Clear? So if I go according to this theorem and according to this diagram, we have a tangent over here, that is DE. This is the tangent. E is the point of tangency, and we have drawn a chord over here, that is AE. Now what is the relationship between this intercepted arc, this one, this arc ABE? It will be, and the angle, what is the name of the angle? AED. So the angle AED will be half of this arc that is intercepted. Okay, so this is the relationship. Now let's solve some questions. This is try number 3. It says given that BD tangent to the circle P at point C. So they are talking about, let me show you, they are talking about this one, okay, where my pen is moving right now. So this is the tangent, this is the point of tangency, and they are saying the arc AC. Now where is the arc AC? Let me show you here. This is arc AC. And what is the measurement of this arc AC? It's 88 degrees. They are saying what is the measurement of angle ACB? Where is angle ACB? Here, ACB. So they want us to find the angle. Now remember, whenever we will be talking about this type of diagram, the angle and the arc will be on the same side, or you can say on the same side of the circle, or on the same segment of the circle, you can say, right? So if you are trying to solve 3a, how can we find the measurement of angle ACB? The same relationship, that the angle will be half of this intercepted arc, so I can say it will be half of 88, it's going to be 44 degrees. Clear? Okay, now what are they saying in 3b? They are saying, now let me erase this one, they are talking about EG. Now what is EG? EG is another tangent that is drawn on the same circle. And what is the point of tangency? The point of tangency is point F. If measurement of angle GFC, where is angle GFC? GFC, so they are talking about this angle is 115, so we can write over here this is 115. What is the measurement of the arc FAC? So where is the arc FAC? FAC, so they are talking about this arc. So as you can see here, all this angle and the arc, they are lying on the same side or same segment of the circle. So it means, what is the relationship between this arc and this angle? The arc will be 2 times of this angle. Clear? So how can we find the measurement of arc FAC? It will be 2 times of the angle, because this is the intercepted arc, so it will be 2 times of this angle, so it's going to be 230 degrees. Clear? Here is the next, try it. It says, given that WY tangent to the circle C at point X, this is WY, this is tangent to the circle circle C at point X. What is the measurement of arc XZ? Where is XZ? So this is XZ, so they are talking about this arc. So what is the angle on the same side? It's 50 degrees. So it means that how can we find the value of the arc XZ? It will be 2 times of this angle, so it's going to be 2 times 50, that will make it 100. So this shows that this arc, this red arc, if I write it over here, it's 100 degrees, right? Now look at the B part. It says, what is the measure of the angle VXW? So if I erase everything from here, where is angle VXW? So this is point V, this is point X, so VXW. So they are talking about this angle. If I want to find this angle, what is the intercepted arc, or where is that intercepted arc? So that intercepted arc is here. So this shows that this angle, the blue one, will be half of this red arc, right? Now, how much is the red arc? I don't know. How can we find this arc? Look at this. This part of the circle is 100 degrees, right? This arc is 100 degrees. And this arc is 196 degrees. How can we find this part of the arc? So let's say, let me explain you. So we are trying to find actually measurement of the arc VX, right? How much is this arc? So can we do 360 and subtract from it 100 plus 196, right? So it's going to be 360 minus 296. Let me check what is the answer. So the answer is 64. So this shows that this part of the arc, let me erase now these ones. So this part, this red part of the arc is actually 64, right? So I will write 64 here now. So this arc, if this arc is 64, how can I get the value of VXW, the angle? So this angle will be half of 64. It is going to be 32 degrees. Clear? So some questions are having many steps, so you have to understand how to get the value of the angle and the intercepted arc, because they have the relationship with each other, right? That's it. Let's start the next question. Now let's solve some questions from the exercise, from the lesson. It says, what is the measurement of arc AD? So here is the arc AD. Now there is no angle. This is the intercepted arc, and we do not have any inscribed angle related to this arc AD. As I told you that some questions will be of 2 or 3 steps. So but I can see that if I extend this arc over here like this one, okay, there's an angle that is the inscribed angle of this intercepted arc BAD. What is that angle? It's angle 68. Now what will be, because the arc is always 2 times of this angle 68, so I can find first the measurement of arc BAD, right? This whole arc BAD. So it's going to be 68 times 2, that will give me 8 times 2 is 16 and 136 degrees. So this whole arc is 136 degrees. How can I find a part of it? So measurement arc AD will be how much? Yes, this is arc AD, because the total arc is 136. From this one, if you subtract 91, it will give you the part AD, and it's going to be 45 degrees. Clear? Now look at the second part. It is, let me erase this one. Now it says, what is angle ADC? Now where is angle ADC? Angle ADC is this one, right? ADC. So this angle, they want us to find this angle. Now the angle, what is the intercepted arc for this angle? Let me show you. This is the intercepted arc, right? This is the arc. So what is the name of this arc? It is arc ABC. What is the measurement of this arc? Because if we know how long will be this arc, it can give us the measurement of this angle, right? So we can say the measurement. So step 1 you can say will be to find how long is this arc, or what is the measurement of this arc. So because this arc has 2 parts, 110 and 91, so we will add it and it will become 201 degrees, right? Now what is the angle that is inscribed? It is angle ADC, the one that we are trying to find. So the angle is always half of this, so you can say divide 201 degrees by 2 to get the half of it. So it's going to be 100.5 degrees. So the value of this angle will be 100.5 degrees. Here is the next question. It says, for these questions, SU is the tangent to the circle P at point T. Find each measure. So here is the first question, question number 26. It says, find the measurement of the arc TVW. So let's see, where do we have this arc? TVW. So they want us to find this arc. So remember, whenever we are trying to find an arc, look for the angle, because the angle can help us to find the measure of the arc. And like, look at question number 28. They want us to find an angle. So whenever they ask us to find an angle, I will look for the measurement of the arc, because the measurement of the arc can help me to get the value of this angle. So it means every time we have to think about the other thing, not, I mean, if they are talking about the arc, I will be thinking about the angle. If they are asking about the angle, I will be thinking about the arc. Clear? So right now they want us to find the measurement of this arc, and because it's here, the tangent of the circle and the point of tangency is point T, and there's an angle over here that is 67 degrees. So it's very simple, using the theorem that we just learned, that this arc will be 2 times of the angle that is made at the point of tangency. So it's going to be 2 times 67. It will give us what it will be, 134 degrees. Clear? Now in the next step they are saying find angle TWV. Where is angle TWV? TWV, let me show you here. This is point T, this is angle W and TWV, right? This is point V, so we have to stop here. So they want us to find this angle. Now when you look at this angle, as I was telling you, I have to look at the intercepted arc. What is the intercepted arc here? So the intercepted arc is here, this one. This is the intercepted arc, right? What is the measurement of this arc? I don't know. But I know something, that the whole arc, this arc WVT is how much? Is 134. So the blue arc is 134, and I want to find a part of it that is the pink one, right? Because only this pink arc can help me to get the value of this green angle. So let's find now. So it means it's a two-step problem. First I have to get the value of the pink arc, that is arc TV. How can I get the value of this arc? I can do 134 minus 74, that will give us 60 degrees, right? So if we subtract from this large blue arc this small arc WV, that is 74, it will give us the remaining part, the pink one, it will be 60 degrees, right? Now how can we find the angle? The angle is always half of the intercepted arc. The intercepted arc is this one, 60 degrees, right? This is 60 degrees. So it will be half of it. When I say half of it, it means multiplied by half or divided by 2. So it's going to be 30 degrees. Clear? Here is the next question. It says HK is tangent to the circle C at point J. Find each measure. Question number 30. It says find the measurement of angle MJN. So this is M, this is J, this is N. So they want us to find the measurement of this angle. So as I told you, whenever they will ask me to find an angle, I will be looking for the arc. So what is the intercepted arc? The intercepted arc is here, M to N, okay? And you know that the central angle and the arc, I mean the corresponding arc, they have the same measurement. So what is the value of the central angle? It's 96. So what will be the value of this arc? It is going to be 96. Right? So how can we find now this angle? Very simple. Angle will be half of the intercepted arc. The intercepted arc is 96 divided by 2, and it will give you 50. Wait, let me check. Sorry, it will be 48 degrees, right? So the value of this angle is 48 degrees. Here is the next question. It says a segment AB is tangent to the circle M at point A. So they are talking about this line. This is tangent to the circle at point A. What is the measurement of angle DAC? So they are talking about the angle DAC. So for the angle, I need the intercepted arc. What is the measurement of arc CD, right? Because only this arc can tell me what will be the measurement of this angle. It will be half of this arc. Now I have a question for you. What is the measurement of this arc, this whole arc? How much it is? Because this is the half circle, so this whole arc, you can say ACD will be 180 degrees, right? And a part of it is 130 degrees. So how can I find CD? It's going to be 180 degrees minus 130 degrees. That will give me 50 degrees, right? So this shows that the part that we were trying to find, this CD, so it's going to be 50 degrees. So this part of the arc is 50 degrees. How can I get the angle, inscribed angle related to this intercepted arc? It is going to be half of it. So what is the half of 50? So the measurement of angle DAC will be half of 50. That means it's going to be 25 degrees. So where do we have this answer? Here is the answer. Okay, here is a challenge question for you. Better pause the video here, solve this question on your own, and then play the video to check your answer. So here is the solution of this question. This question can be done with two methods. The way you understand it, you can do it like if you go with method 1, then some of the students, they like to find this angle first, because we are trying to find that how much is this arc WXY. So they find this angle that is actually becoming 76 degrees here. So the arc intercepted arc with this angle WXY, it will be 2 times of this angle, that will be 152 degrees. And some students, they do not solve it in this way. First they find the other part of the arc, this part of the arc. How? Because this arc, this intercepted arc is related to this angle, so it will become 208 degrees, right? So if you want to find the other part of the arc WXY, it will be 360 minus 208. That would also give you 152 degrees. Clear? Here is the next challenge question. They said, what is the measure of arc BC? Pause the video here, solve it on your own, and then play the video to check your answer. So here is the solution for this challenging question. It's really very difficult question for you maybe to understand, because this is the inscribed quadrilateral, and we will find each angle of the inscribed quadrilateral, and you know that the sum of the opposite angles of the inscribed quadrilateral is 180. So we can subtract 98 from 180 to get angle C, and similarly we can find angle B, right? After that, how can we find these arcs, like arc DC, or you can say arc CD, and how can we find arc AB? Look at this. Because each arc is lying or intercepted by an angle, so if you are trying to find arc AB, where's arc AB? This part of the arc, right? So it is actually inscribed, or it is in front of this angle C, right? So if you multiply 82 by 2, it will give you this whole angle, this whole arc BAD. That will be 164. So if you subtract this 80, a part of it from 164, it will give you 84 degrees. So this arc AB will become 84 degrees. Follow the same steps for the other for the CD, and when you will get this part and this part and this part, so when you subtract these 3 parts from 360, it will give you the value of the arc BC. Pause the video here, try to understand each and every step, and then move to the next questions. Question number 27, and as you already know that we found this answer, I think it was 134 degrees, and we found the answer of this one on one of the slide, and it was 30 degrees. Okay, now here they want us to find angle TWX. So here is T, here is W, and here is X. Let me show you. They want us to find this angle TWX. Okay, so whenever we want to find an angle, we need the intercepted arc. Now how much is the intercepted arc? Let me show you. Here is the intercepted arc. So it means if I know what is the value of the intercepted arc, it can give me the value of the inscribed angle, right? Now what is the measure of this whole arc? This whole arc, let me call it, let's say WVX. So because it is, this arc is like half of the circle, so this whole arc is going to be 180 degrees. Now look at the pink part that I'm gonna draw now. So WVT, how long is this arc? We already know TVW or arc WVT, it is the same, it is 134. So this pink arc, we already know it's 134 degrees, right? And even if you do not know, 67 times 2 will give you the value of this arc. It is a semicircle, so I can find this whole arc WTX. It will be 180 degrees, right? Now how can I find arc TX? It will be like if you subtract 1 from 180, this 134, it will give us what? It will give us 46 degrees. That will be the measure of this green part, right? This one. So how much is this arc? It is actually 46 degrees. Let me write it over here. So this is 46 degrees. How can I get the angle that is inscribed? Okay, it is measurement of angle. This is question number 27. So measurement angle TWX. How can we find the inscribed angle? Using the intercepted arc. The intercepted arc is 46 divided by 2. So it's going to be 23 degrees. Clear? Here is the next question. Next homework questions 23 and 25. Better pause the video here, solve these two questions on your own, and then play the video to check your answers. Both the questions are very simple. Here they want us to find the measurement of the arc BDC. When I highlighted it over here to find the measurement, it's because this part of the arc is 110. So if you subtract 110 from 360, it will give you the measurement of the arc, that is 250 degrees. Similarly, here in question number 25, I have highlighted the question, the angle they want us to find. They want us to find the angle BAD because it's an inscribed quadrilateral or the cyclic quadrilateral. So the sum of the two opposite angles will be 180. So if you want to know one of the angle, you can subtract the given angle 68 from 180 to know what will be the measurement of angle A. Clear? So here we have two more homework questions, very easy. Better pause the video here, solve both the questions on your own, and then play the video to check your answers. So here are the answers for both question number 29 and 31. For question number 39, they want us to find this angle. Let me show you here. They want us to find this angle KJM. To find this angle, I need the intercepted arc, that is JLM. And to get the value of this arc JLM, I have to subtract 126 and 96 this side of the circle from 360. So it is giving me 138. So if the intercepted arc is 138, how can you get the value of this angle? It will be half of it, that is 69. So then in question number 31, they want me to find this angle. So this is the easiest one because we already have the value of the arc, and this one is the tangent. So the angle that will be here will be half of this intercepted arc. So it's going to be 63 degrees. That's all for this lesson, girls. Hope you understand it.